Hey you guys, welcome back. So we're going to be starting our next topic. This is actually the next chapter, which continues. We're learning about statistics. This is going to be section 10, topic 1. It's the relationship between two categorical variables. And we're going to be discussing marginal and joint relative frequency. So that was like a lot of words. Statistics often comes down to making sure that you understand the vocabulary to make sure that you understand what's being asked of you in the problem. So it's going to be really important that you memorize what these key words mean and learn their definitions. So let's just jump right into the notes here. This is actually a document available on Google Classroom. It's 3 pages and it includes the notes and the practice problems. Okay, so if we start over here, we're going to see that we have two categorical variables and they can be represented with a two-way frequency table. So remember, a categorical variable is when you're counting something that falls into a category. So if you're categorizing this data, you could have like men versus women, or a particular favorite color or a favorite subject or something like that. And that's actually what our first example is going to look like. So, and a two-way frequency table, it counts how often somebody falls into two different categories in a set of data. So we're going to use this example below. It's a survey that says 149 elementary students were asked to choose whether they prefer math or English. And the data was broken down by gender. So those are our two categories in this example. We have the gender of the student, which is going to be male or female, and then we also have favorite subject between math and English. So that's our other category. Okay, so between the males, there were 42 males who prefer math and 47 who prefer English. And then in the female category, there were 35 females who preferred math and 25 who prefer English. So a two-way frequency table is a visual representation of the frequency counts for each categorical variable. It's kind of what I was just explaining. And the table can also be called a contingency table. So contingency table and two-way frequency table are synonymous. They mean the same thing, okay? So let's go ahead and get started filling in this information. So elementary students' subject preferences. So where males and math intersect in this first cell, we want to go ahead and enter our data. So that's going to be 42. And then for the females who like math, that was 35. So we're going to put 35 here. And then males who liked English, there were 47. And then for females who preferred English, that was 25. Now the rest of these cells that are in this table right here, I'm pointing to them right now, they're outside on this table. They're actually in the margin of the table, and that's going to be the key for you to remember. When something is asking you for the marginal frequency, they want to know these values that are on the outside, okay? It's what a marginal value is it's a total of a row or a column, okay? So for example, let's see, the total frequency for any row or column is called marginal frequency. And why do you think these frequencies are called marginal frequencies? Because they are in the margins of the table. Okay. And a joint frequency is the count in the body of the table that join one variable from one row and one variable from one column. So that means every number that you see here is representing a joint frequency. So if you want to think about that in another way, when you say that you're like joining someone else in class to do like a project, that's the two of you coming together to do something, to finish like an assignment. In this situation, when we're talking about joint frequency, we're looking for a count when those two categories intersect with each other. So we don't want to just know how many males were surveyed. We want to know how many males were surveyed that liked math and how many males were surveyed that liked English. So these values right here, I'm going to circle them. These values that you see here are called joint frequencies. I'm going to circle this, okay? And why do you think they're called joint frequencies? I mean, I kind of just explained it, but it's when two categories join. Okay, it also says draw a box around the marginal frequencies and then circle the joint frequencies. Oh, that's why I circled it. Okay, so we circled the joint ones already. We need to put a box around the marginal ones. That would be this count down here, this count down here, this count over here, and this count over here. And, you know, we probably shouldn't leave them blank. We should probably figure out what they are, right? So if you add 42 and 35, this is 77. So the total number of students surveyed who liked math, regardless of whether they were male or female, was 77, okay? That's what this number is telling us. And then for English, it's 47 and 25. So if you take that up, that's 52. So it's going to be 72. And then when you add these numbers together, so if I'm adding up all the students who liked math and all the students who liked English, I should be getting the total of people that was surveyed. So you may or may not have that information already. We were already given that in this problem. It was given to us as 149. So 70 and 70 makes 140, and 7 and 2 is 9, so that's 149. So this is correct, okay? Now, when we go across through the rows, what we're adding up here is the males who were surveyed who liked math and the males who were surveyed who liked English. So if you combine those together, you're going to get 40 and 40 is 80, and 7 and 2 is 9, so 89. And then 30 and 20 is 50, and 5 and 5 is 10, so that's going to be 60. And 89 and 60 is going to give us 149, so that is correct, okay? Let's see, draw a box. Okay, so we're done with this table, essentially. The two-way frequency table or contingency table is done, okay? I'm going to draw another arrow here because I want you to understand that this right here is the frequency table or the two-way frequency table or the contingency table. Okay, I'm going to turn the page here, and I'm going to keep that handy because I think I need it to answer the next set of questions. So frequency tables can be easily changed to show the relative frequencies. And to calculate what a relative frequency is, you divide each count in the frequency table by the overall total. So for example, in a relative frequency table, what you're going to see is not a count anymore of how many students liked math or English or how many males or females. What you're going to see now is a percentage because the table is now representing what percentage of males preferred math in comparison relative to the total number of students that were surveyed. So that's where that word relative is coming from. So you can't just say how many males like math. That number has to be relative to something, because if I just asked you how many males like math, well, your next question should be, well, out of what population? Are we talking about every male in the entire universe? Are we talking about every male in Palm Beach County? Are we talking about every male at Palm Beach Central High School? So you have to relate that data to something, and that's why it's called a relative frequency, because it relates to the total. So if I refer back to my last table here, and I'll actually show it on the screen right underneath it, okay, so we have the counts here. The students who were male who preferred math were 42 out of 149. So we just need a calculator. We just need to divide those so that we can tell what that number is as a percent. And whatever that answer is, you multiply by 100. So this is 42 divided by 149, which is 0.32. I'm going to round it. It's like 0.329. So if you write this as a percentage, it's you multiply this by 100, and that's going to give you 32.9%. Now, I tried to jam a whole lot into that box. For the rest of them, I'm just going to put the percentage. I really just did this so you could see how I got this figure, okay? So let's do the female one who liked math. Female students who liked math was 35 out of 149. And we take that value that we got and multiply it by 100, and we get 23.5. I'm rounding here, of course. And then we can do males who preferred English. That was 47 divided by 149. Oops, I did that wrong. 149. Okay, and that's going to be 31.5. And then we need to do females who preferred English, which was 25 out of 149. So 16.8. Okay, now at the end of the day, you're going to do a similar process here to find these marginal relative frequencies. So you just add across and you add up and down to get what these are. So 32.9 plus 31.5 should be 64.4. And then 23.5 plus 16.8 gives me 40.3. And then down here we have 32.9 plus 23.5. Whoops. That's 56.4. And finally you have 31.5 plus 16.8. That's adding up and down, and that gives me 48.3%. Now, the very last thing is that this box here, this is going to be 100%, and it's going to be 100% always, no matter what, because this box in the corner represents your total. I'm going to not use a circle or a box here. I'm just going to use these ziggity-zaggities, okay? So this number represents your total population that you surveyed, okay? So no matter what, that's 100%. Now, if you go back to our last table that we made with the counts, when you add these two values, you should get the total. So that means when I add these percentages, it should be adding up to 100. So if I do 64.4 plus 40.3, I get 104.7, and now I'm starting to think that maybe I did some math wrong. So let me just double check my work. 42 over 149, 47 over 149, that's 20, 31 and a half. Oh, I know what I did wrong. Okay, so actually my error seems to be actually with my first calculation here, so let's fix that right now before we go any further. So this value, I'm going to draw an arrow because I'm going to do the work up here, okay? This should have been 42 out of 149. I'm not sure what I keyed in, but that comes out to 0.28, which is 28%. So, okay, because I messed that one value up, now I have to redo this calculation and redo this calculation. So let's do that real quick. 31.5 plus 28, that gives me 59.5. And let's do this one again, up and down. That should be 28 plus 23.5 is 51.5. Okay, so anyway, back to what I was saying now that that's been fixed. So if I add 59.5 and 40.3, I should get 100, or in this case, I'm probably going to get really close to 100. When I do that math, I end up with, I'm not sure if you can see my calculator, but I end up with 99.8. I'm going to tell you that's okay, because what happened as I was doing these calculations here, what was I doing? I rounded them. So if I really took the exact values of these percentages, they're going to be super long decimals, and if you add them together, you will get exactly 100. But I know this is happening because I rounded, and it's okay for you if you round it too, and it's pretty close, because this is only 0.02% off of what it should be. Let's double check the row too. So these two totals should add up to 100 or really, really close to it. And I get, again, 99.8. So I'm sure that's just a rounding issue, and it's okay. It's close enough to 100 for what I'm looking for. Okay, so the question says, why do you think these ratios are called relative frequencies? Because they relate to the total. That's the key word. They relate to the total. Draw a box around the marginal relative frequencies. So remember, marginal means the ones on the outside. So a box here, a box here, a box here, and a box here. And then your joint relative frequencies are going to be the values inside the table. All right, so the joint frequency would be the count of males who like math, or males who like English, or females who like math, and so on. And the reason this word, because this word relative is here, that means we have to relate that count to the total. and we would take the 42 of students that there are and divide it by 149 and get a percent. So we're going to draw circles around these. So circle, 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 circle. Okay, and then it says interpret the marginal relative frequency for male students. So male students, marginal relative frequency would be the outside value here, 59.5%. So what that means to me is that it means that out of the population, that means that 59.5% of the students that were surveyed were male. It has nothing to do with math or English, okay? This is specifically talking about this row only, okay? So 59.5% of the students were male. Okay, and it says also interpret the joint relative frequency for females who prefer math. So if you go into this, joint relative frequency is going to be one of these inside values. That means 23.5% of the students surveyed were females who liked math. So let's do that. 23.5% of students surveyed were females who prefer math. Okay, that's all there is to this lesson, honestly. So if you take a look at the next side, this side over here that I'm pointing at right here, this problem is going to be a practice problem for you. It's going to be considered classwork. So I'm sure you've caught on to the scheme so far of my grading. So I'm taking 2 points for your note-taking skills. So that's all the notes we do together in the videos. And then 2 points for the classwork assignments or the practice assignments, the practice problems that you get that go with each section. So you're going to have this as a classwork problem. And then when we flip the page, you're going to have this one and this one as a classwork problem. And when you're finished with all that, you're going to take a picture using the apps on your phone or your Chromebook screen, and you're going to go ahead and upload that into Google Classroom under this assignment. If you have any questions about this topic, please feel free to come to my next office hours. Since this is Wednesday's video, the next office hours that you'll be able to attend will be tomorrow or Thursday between the hours of 10:30 and 1:30, and the code will be posted on Google Classroom. All right, you guys, I will see you next time. Bye-bye.